after each newly created letter that we've created, we're going to add that letter's number in the alphabet. So A is 1, B is 2, C is 3, L would be 12, right? And then we're going to return that message. Okay. So let's see how that hash function looks like. And if that would be a good hash function, right? So we have the mtg hash, right? And let's give it a message. So let's have the first message be, let's say cat, okay? So if I give this function the word cat, what it's gonna do is first, it's gonna increment everything by 1, right? So C becomes D, A becomes B, right? And T will become U, right? Then, so that's step 1. Step 2, let's add the letter of each of these after them. So A, B, C, D. D would be 4, so we'll put D, and then after D, we'll put 4. B would be 2, so we'll put B2, and U would be 21, so we'll put 21 here. So this is the hash value would be D4B2U21. So if this was your password or your message that you wanted to return a hash, this would be the return value. Now, if you looked at this, you might not be able to predict that this came from the word cat. But then let's say you give it another message. You have another message, and this is message 2, and this here you say dog. Well, again, step 1, we take the message dog, we increment it. So D would be F, right? We'd have O, so that would be P, and we'd have G, which would be H, right? We increment everything by 1. Step 2, we add the letter. So F, the letter for F in the alphabet is D. Oh, sorry. So here should be D-E. So E comes after, let's erase this. So after D, there's E. It's not F. Apologies. E. So E would be A, B, C, D, E, 5. So we'll put E5, right? Then we have P. P is the 16th letter in the alphabet. And H is going to be the 7th letter in the alphabet. So the message or the hash would be E5P16 H7. So we have this hash. Now, if you did these two messages, you might find that something is similar. Oh, we have these numbers that came in from nowhere. You know, what are these numbers here? Maybe I can take them off and they're worthless. You know? Oh, and hey, E, this is the letter after D. Maybe if I just subtract 1 from each of these, then D, before P is O, before H is G. Oh, I have dog. So you can reverse engineer it. And you notice that because by trying different messages, you saw that there was a pattern and you can reverse engineer it. So this would be a very, 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 very bad hash function because it does not, have the properties that a good hash function has. A good hash function would, efficient to compute. This one was efficient to compute, very easy to compute, right? Hides the information of the input. It doesn't hide them. It doesn't hide the information. I could see that information there, right? So somebody can reverse engineer it. The output looks random. It doesn't look random. So that's a very bad hash. Collision resistant. No two messages could look alike. I guess that might be true. We'd have to test it more. But it's not a good hash function, right? Obviously not. And also the return should be a fixed size alphanumeric string. These ones were not fixed size. If I had a longer message, it would return a longer message. So that's not a good hash function. Now, if you want a good hash functions, we can look at the other ones, but this really serves to show you what is exactly a hash function. Anybody can create their own, but if you really want to create a good hash function, it's super hard, right? Now, these are actual hash functions, right? There's the message digest 5, which was one of the first ones created. Then you had like the SHA secure hash algorithm, which is the most widely used hashing algorithm out there. SHA-1 was the first one that came out, then SHA-2, and all of these are like subsets of the SHA-2. So SHA-1 was super secure in the beginning. Governments used it. Everybody used it. Now, with computing power being so strong, people have been able to reverse engineer it. So it's not a secure hashing algorithm anymore. People don't use it. The most popular one right now is the SHA-256. It's actually the one that Bitcoin, the Bitcoin protocol uses, right? So these are very secure, you know, SHA-256, 384, and there's way many more hash functions, right? Very secure hashing algorithms. And we can look at it right now and see how secure these ones are, right? If I open this, let's see here. So yeah, you have, what's this? You have a bunch of websites where you can give a message and it returns you the hash based on that algorithm, that cryptographic hash algorithm, right? So here there's a website that converts things based on the SHA-256 cryptographic hash function. If I go here and I say cat, well, this is the hash of cat, right? Cat, T. This is the hash of cat. Now you see that this looks absolutely random. It hides the information from here. You cannot reverse engineer it. And if I had something else, like let's say dog, it would give me something completely different. So it's collision free and it's always a fixed size return, right? And I can write something here, and this is, let's say I write a long sentence like Montreal Trading Group is the best one, okay, for this message, okay, and let's actually input this in a Word document. Let's go here, and I'll go, apologies, let's go in, or a text file, or Notepad. Let's go Notepad++. Here we go. Okay, so for this message, oops. So for this message, I have this hash, right? Now, imagine I change the message just by one letter. One letter. Instead of one, I'll put two. Look at this. Just for a one letter change, right? Look at the new hash function. It's completely different. Completely, right? So this algorithm is so good that if you change just slightly anything, the return is completely different. So if you compare the hashes, you know the variables are different. Very secure. You can't reverse engineer it. So this is a secure hash function. And again, this was just to, you know, make you understand what hash functions are, how they are used. They're used everywhere for security, and there are very strong hashing algorithms, and there are weaker hashing algorithms. And with times, we need to evolve the hashing algorithms to make them stronger because computing power becomes better, and then weaker hashing, or even hash functions that were strong at one point become weak, and then we need to use something more secure. Now, once we get to the blockchain course, we're going to see how hash functions fit into the blockchain and how they make all the properties or protocols of the blockchain work in a way. So I'll see you guys in the next lecture.